its own real-time tasks and their requirements. So it has to specify their requirements to the hypervisor so that the hypervisor can provide real-time scheduling. The interface is to specify aggregated real-time workload. We introduce a new hypercall, hypervisor request out schedule, which takes 3 parameters for calculating the optimal interface. UW means workload utilization, algorithm, and minimum period in task set is required. And we have modified some code in the source. And this is our implementation. At the guest OS side, it calculates the workload utilization and gives the real-time scheduling information, as I have explained, to the hypervisor. And the setup side, it calculates the optimal interface, which takes the minimum CPU overhead, and it adjusts the guest scheduling parameters. By taking this algorithm, the hypervisor finds the optimal interface without giving the heuristic engineering report. By using this algorithm, you can use real-time without any further consideration. And I will share our experiences. We have ported real-time guest over Xenon platform. MicroCOS is a educational and research purpose real-time operating system, and we actually parameterized the MicroCOS to Xenon platform, so named MicroCOS 2-Gen, and our parameterization is based on mini operating system. And because the former MicroCOS was written with IAR C compiler toolset, we performed a lot of engineering effort to change it to be compiled with GCC toolset. And we can run simple real-time application with the GCC toolset, and it provides idempotent memory mapping, so you can use hardware memory without any modification. And MicroCOS's original scheduling algorithm has not been changed. And it has posted on several sites. You can refer them. This is more interesting our plan to go. And this is for hardware platform is we want to run the real-time operating system with the general purpose OS such as Linux. And our hardware platform is Freescale IMX21 platform, which runs 266 MHz and runs 9 CPU. And software is set up with General Linux 26.18. And we use SCDF with Context Compositional Scheduling Interface. And our current software workload is MyBench-based emulation for real-time. And for non-real-time application, we just use Linux lab applications. Currently, MyBench is used. MyBench is a embedded system benchmark, macro benchmark tool, which includes the telecommunication, automotive, network security applications, and we use telecom and GSM encoding and decoding tools. This is preliminary result, and is doing underway. This is not so optimized, so you can just get the sense of numbers. GSM encoding, the standard 133 frame encoding time has taken about, in Xenon Linux case, average 220 milliseconds, and in MicroCOS Zen runs about average about 4 milliseconds. So, and be aware that JSON frame time is 4.25 milliseconds. So if you do some calculations, General Linux, it takes about 1.3 milliseconds average. So it is almost tight. It's much tighter than MicroCOS case, and you can do some real-time application using the MicroCOS. Current difficulties in porting the application is the actual MyBatch uses C library. GCC is compiled with GCC, so it extensively uses C library. However, in MicroCOS, several C library functions are omitted, so we have to modify the code to work with MicroCOS. And for measuring the fine-grained time, at Dongyu there is no, some registers are not available at Dongyu, so hypercall has to be invoked, and the hypercall overhead exists in Dongyu. So this is our conclusion. I have presented a real-time possibility in Xen, and this real-time scheduling issue has been reported. We are dealing with how to set up the scheduling parameters, and we are saying that by giving several information to the hypervisor, we can schedule real-time very easy way. And we have modified Xen to schedule actual real-time virtual machines, and we share some experiences and present some preliminary results. Thank you. If you have any questions. Any questions?
So, since that this effort is based on the modification of both domain 0 and domain U OS. So if we want to support unmodified guest OS, how will this effort be achieved?
Okay, actually we are doing parameterize, so we modify some code of the MicroCOS, and MicroCOS is currently running at Dongyu and it can be run as Dong0 also. And is it enough for?
So my question is, if you want to run an unmodified OS, is it possible to?
Not in plan. Currently, not in plan.
Thanks.
And the articles has a dependence with the domain 0. So how to deal with the dependence?
Okay, our last presentation in last Xen Summit, we gave some plans, and one is how to deal with schedulability issue to provide determinism as presented in this presentation, and we have planned to deal with the predictability and interrupt-related problems. And currently, the solution is not so clear, so we need to clarify.
Very difficult.
Yeah, sure.
Okay, let's give thanks to the speaker.